This is a quick introduction to the Mumps programming language. First of all, Mumps history. It began around 1966 at the Massachusetts General Hospital in Dr. Octo Barnett's laboratory. It was originally designed and written by Neil Pappalardo, Bob Greenus, and some others. It was initially implemented on a PDP-7, which was a donation to the laboratory. The PDP-7 from Digital Equipment Corporation, then a very small company, had no operating system to speak of on it and very limited language support. So they were confronted with the problem of how to use the system. So what they did is they wrote their own. So initially, Mumps was not only a language, but it was also an operating system and a database system all together. The operating system supported time sharing. Even on this small primitive machine, they could have multiple partitions servicing different users simultaneously. And it would schedule the users in a round-robin fashion. And all of the users could access the same database at the same time. It was fairly advanced for its time. It was only a year or so earlier that Dartmouth Basic got into operation, which is generally considered one of the earliest successful time-sharing systems. This is an overview of the original Mumps operating system on the PDP-7. And it was also on the PDP-11. It was quite a while before Mumps actually became a language running under an operating system. Nowadays, it's run in Linux or Windows. It's not its own operating system. In the earliest days of the PDP-11, which could have the maximum memory on a PDP-11 was the equivalent of about 144,000 bytes. Very limited memory. I don't know how large the machine they had at Mass General was, but it was certainly no larger than 144,000 bytes. Now, what they did is they wanted to have a time-sharing system so they could have multiple users. And so each user would get a small partition. And the partitions were small, only 1,000 or so characters, in which you had to put all of your code. There would be a Mumps language interpreter, which would execute the code it found in these partitions. And it was executed from source. It was not compiled. It was executed from actual source code. I'll get to that in a second. There was a global array file manager, which was invoked by the Mumps language interpreter in order to retrieve or place data onto the disks. And finally, there was an operating system, which was essentially a scheduler and I/O manager. It manages system files, printers, and other devices that were on the machine. So what you did in Mumps is you had a program that was in source code, and you would load it into a partition, or at least the operating system would load it into a partition, and the interpreter would begin to interpret it. As it interpreted it, it would, from time to time, call upon the global array manager and to retrieve and store data. After a certain amount of time of you executing, the system would switch to another partition, and it would go round robin like this, back and around, giving each user a time slice. Now, one of the interesting things about the early history of Mumps is they tried to decide whether or not it would be better to compile the programs and load executable modules in, or to run them from source code to interpret them. And the decision was that it was better to go interpretive. Since the language is so database intense, most of the activity is basically waiting for input-output. Another thing is they determined that if they compiled Mumps programs, the size of the executable stored on a system disk, the amount of time to load and store the file would actually be significant. Since we're not really using Mumps to compute nuclear physics here. It tends to process some strings and do some I/O, and the I/O is really where the programs are in their wait state most of the time. So they went with the interpreter model. That's still used. Mumps is still basically an interpretive language. The GTM version of Mumps does claim that they compile it. I've not seen the evidence. But at any point in Mumps, you can actually create code and cause it to be executed. So someplace there's an interpreter sitting around. I'm pretty sure InterSystems is still mainly interpretive. But in any way, mine is completely interpretive. I do have a compiler, but the interpreter is the one we'll be using for an example. So that being the case, and being that these partitions were very small because of the early machine, a lot of Mumps is very concise and very abbreviated. As a matter of fact, every command in Mumps and every function can be abbreviated down to 1 or 2 letters, which And you will see that if you look at the Veterans Administration Code, everything is abbreviated and compact. It looks like somebody sat on a keyboard. It is very difficult to read unless you know what you're reading, because the delimiters are spaces, and it becomes quite unreadable at times. But nonetheless, that was the reason for that, is so you could pack as much code into a small partition as possible. And that's still true to this day. Mumps programmers abbreviate everything, and to an outsider that looks really confusing. In reality, it's not. But this was the original layout, and eventually it gave way to an operating system being either Windows or Linux or something here, and using the file managers that are available in Linux and Windows. So a lot of this bottom part, and of course the alternating from partition to partition, more or less went away. In any event, Mumps has developed over the years and is presently used in a number of medical applications, most prominent of which would be the U.S. Veterans Administration VISTA system, which has been ported to a number of commercial applications. Mumps is widely used in medicine. You may not see it, but if you've been to a hospital or to a physician's office, the computer they're working on, more than 50% of the time, is running Mumps programs. It's no longer usually an operating system, but it is programming language more now. The acronym stands for Massachusetts General Hospital Utility Multi-Programming System. Mumps. That was back in the day, of course, in the 60s. Acronyms were Fortran and COBOL and BASIC. So they decided, since it was medical, they'd go with Mumps. Probably not the best choice, but nonetheless, that's where it is. The attempt to use the word M kind of failed. It is generally referred to as a multidimensional and hierarchical database facility. What that means, and we'll get into it in great detail later on, is that the database is represented in the language as array references, and each successive index in the array actually describes a path through a tree. It can be viewed that way anyway. Or you could look at it as an n-dimensional array, sparse matrix. Both views are valid. The current implementations that are out there is, first of all, InterSystems, and their implementation is called Cache. They don't even use the term Mumps anymore. They've added a number of features to the Mumps language. They've made it object-oriented, and it's widely used, and it's very extensive. FIS Corporation, they distribute something called GTM Mumps. It is open source, but they do sell support. And theirs is also widely used. There's my particular version, and all of the examples we give in this tutorial will be from mine. And then there's a version from Ray Newman, which is available on SourceForge. I am not familiar with it, but it's been around a while. You may want to take a look at it. There are the links on the page. Each of these has different dialectical features. In Mumps, you are allowed to add what they call Z functions and subroutines and variables and so forth. So there will be some differences between the different dialects, but they're extensions. They're not the core language. In my version of Mumps, there's a brief description here of how to go about running a program. We'll see that when I actually run some programs live here. But essentially, it works under Linux. It can run under Windows, but you're smart to be running it under Linux. It'll be better supported. You can either just type the name Mumps, and up will pop a command line interpreter that you can type Mumps commands to. You can tell it to run a particular file name, go to up arrow file name.mps, and it'll execute that file. Or you can type in the command Mumps and the name of the file you want to execute it. Or you can just make the file itself, filename.mumps, executable by incorporating on the first line that. That is fairly standard Linux, Unix nomenclature, #bang, /user/bin/mumps. That's the location of the Mumps interpreter. And if it sees that in the first line of a file, and if the file is executable, it will send the file to the interpreter, and you're on your way. First of all, we want to look a little bit about Mumps syntax. It's different than modern language syntax. It's not a modern language. It's a very old language, much like Fortran. The syntax is very important, and this is sometimes difficult to get across to people because they think in terms of, well, it looks better if you put blanks like this, which is the way you would teach someone how to do it in a programming class. It's more legible and clearer and so forth, rather than this dense code here. However, this is the way it must be. In Mumps, blank is a delimiter. So if you add blanks between the variables and constants, you're ending the statement. So this here would end at var. It wouldn't see the rest of that. It would get very confused very shortly. It would assume that the equal sign was the next command, and it would promptly tell you it's an unrecognized command. So no blanks, please, except within quoted fields. The semicolon you'll see at the end of a line, it means the remainder of the line is a comment. That was the early back in 1966. ASCII didn't even have semicolons. It was a new idea anyway. So it was a otherwise mainly unused term in most programming languages. So the semicolon is not the semicolon in the sense of a C or Java program. It introduces the comment. The remainder of the line is a comment. Okay, so we've got we'll get more on syntax, but just remember no blanks unless you really mean it. Variables. There are two types of variables in Mumps. They're called local variables and global variables. Global variables are stored on disk or some other external medium, usually disk. And they will continue to exist once the program dies, terminates, goes away. Local variables are in memory. They're created by the program, and they disappear when the program terminates. They're normal variables that you would have in a regular program. A Mumps variable name has to begin with either a letter or the percent sign. In Mumps, percent sign is a legal character in a variable name. Not in other languages, but it is in Mumps. So a Mumps variable begins with percent sign or a letter, uppercase or lowercase. And it may be followed by letters or numbers or the percent sign. No underscores. Underscores mean something different. No dollar signs. Dollar signs mean something different. So a Mumps variable starts with a letter or a percent sign, consists of letters, numbers, or percent signs, nothing else. Don't add underscores. That means it's actually the concatenation character in Mumps. Don't use it, unless you mean it. The other thing is the distinction between global variables and local variables. Global variables are preceded by an up arrow or circumflex characters. Local variables are not. That's the only difference. Otherwise, they pretty much behave the same. There's some minor issues, of course, but for the most part, local and global are transparently similar. The difference is that circumflex at the front of the variable. Contents of Mumps variables are stored as varying length character strings. The maximum length of a string in storage depends upon the implementation. I don't know what the others use. They may be unlimited effectively, I'm not sure. The original standard specified 512 characters, and I'm sure everybody is much higher than that. Mine, it's 4096, and it's a settable parameter, which is usually more than enough for a typical string, but who knows. In Mumps, there are no declaration statements. You do not declare variables, because variables are basically all one type. They're all strings. Even if they're numbers, they're represented as strings. So there are no declaration statements. You create an array. You just create elements of the array. There is no pre-dimensioning or anything like that. They don't deal with dimensions because everything's a sparse array. The data is there if it's there. If it's not there, it's not there. We'll see that shortly. They're created as needed when they're used. In other words, if you assign a value to a variable and the variable previously did not exist, it does now. It creates the variable. If you read into a variable and the variable does not exist, it creates it. So there's certain things that result in variables being created, and they are associated with read and assignment, and there's a couple of other commands. There's a new command which will allow you to create variables. And there's also the merge command, which creates variables as needed. The opposite of that would be destroying a variable. How do you get rid of a variable? Now, of course, if you just exit the program, all the local variables die. But in the course of a program, you may want to destroy some variables for some reason or another, and that's the kill command. The kill command deletes a variable. It works on both local variables and global variables. It's more likely to be used on a global variable, where you want to edit the contents of the disk. Another thing about the kill command is that when you execute the kill command on a global array, and global arrays, as I mentioned, are represented as though they were array references, parentheses 1, comma 2, comma 3, comma 4. They do use commas and they do use parentheses, much like Fortran does. If you kill something at the first level, it destroys all descendants of that item. We'll see that again. So the kill can be more extensive sometimes. Otherwise, if it's just an ordinary scalar variable, it kills that and that alone. In the earliest versions of mumps, in original implementation, you didn't pass parameters. And nowadays, that's true. You can pass parameters to subroutines. As a consequence of variables not being passed as parameters, all variables were known to all functions. If you invoke a function, it will know everything that was in the calling program. And anything it changes will affect the calling program. Now, in the newer versions of mumps, they've added to this, and so we'll see that later. So you can pass parameters, and you can set it up in the subroutine that if it alters something, it won't affect the calling program. We'll get to that. Mumps variables are not typed, as we mentioned. They are all strings. The basic data type is string, but if you have integer or floating point or logical, these can be performed on the variables if their contents are appropriate. And we'll see that shortly. The values in a string are usually at least the ASCII characters between 32, which is a blank, and 127, which is the del or delete key, actually, decimal inclusive. Now, some implementations will have additional character settings for other languages and so forth. Mine, I only do the 32 to 127, but check with the documentation. And I mentioned the set, merge, and read commands, and there's also the new command for creating variables. Array references are formed by adding a parenthesized list of indices to the variable name. So here we create, this is a reference to an array. Since there's no circumflex, it's a local array. So it's the name of the array, and it's a properly formed name. It starts with a letter. It's lowercase. Lowercase is different than uppercase. And it has 3 indices. The first level index is a string. Perfectly okay. You can have string indices in mumps. The second is a number, and the third is a number. So this is an array with 3 indices. You might say it's a 3-dimensional array. Or you might say it's a tree, the top node of which is labeled ABC. Then beneath ABC is a node labeled 2, and beneath 2 is a node labeled 3. There could be other branches in this tree, but this would be one branch, one sequence, one path from the root. Indices may evaluate to numbers, strings, or both. If you're using strings, they're going to be quoted. As you see with ABC is quoted, notice it's a double quote. Double quotes are used to quote strings. Numbers need not be quoted. If it's a number, you can leave the quotes off. If the number has leading zeros and you leave the quotes off, you're going to lose the leading zeros, by the way, because numbers are treated canonically. If you want to keep the leading zeros, you'd have to put it in quotes, and then the leading zeros would be that's a very rare situation, however. Okay, some example variables. The set, by the way, everything in mumps is a command. They're not statements, they're commands. And every operation begins with a command word followed by an argument. And the set command word is assignment, which I think was the same they used in BASIC back at the time. In any event, this is an assignment statement, and it assigns the value 123 to the variable %. Perfectly legal variable name. It's kind of an odd one, but it's legal. And so if necessary, it will create the variable %, and it will assign the value 123 to it. Now, that'll be stored as a string, but that's fine. The remainder of the line is a comment because of the semicolon. Now, the next line here, we see a global array being assigned. Again, we're going to assign 123, no significance to what we're assigning, just something we're assigning. And we're assigning it to a global array called x1, and we're going to put it it's going to be indexed by the word dux, okay? That's an index, a perfectly legal index. And we can see it's a global array because it has a circumflex. If this node in the global array did not exist in the global array system, it would be created. And we would have a global array with, at least it may already exist in other places, and there could be an x1 parenthesis chickens. I don't know. I can't tell from just looking at this. But we do know there's at least one node, and its index is dux. All right. This is names are case sensitive. I don't know why Fido is here, but anyway, they are case sensitive. Uppercase Fido would be same as it would be different than lowercase Fido. This is a local array. Again, I used a string index. Doesn't mean you have to use string indices, but that's what we're using at this point. And it would create the local array element if necessary and assign it 3.141. It should be 15, I guess. But anyway, this is a global array X. The index value is 100, and we're reading something in, presumably reading it from the keyboard, or it could be from some other device, but let's assume the keyboard. That's the default ordinarily. Now, if this element in the database did not exist, it will create it, and it will store in it whatever it reads. When it reads an entire line until you hit carriage return. When you hit carriage return, that everything you've typed is the item you read, and that would go into the node. This is a scalar. Again, percent sign is perfectly legal. This is not legal because the variable name starts with a 1. You'll get an error message. This is not legal because it's got an underscore. That's actually the concatenation character. And this is not legal because it starts with a $sign. $sign is not permitted in variable names. They mean something else.